Okay, so today we're going to look at how much heat is lost when 100 grams of steam at 115 degrees Celsius condenses and cools to form water at 95. Okay, so it's important for us to first of all realize that um, we have steam and there's going to be a change of state. So steam, this is just my little drawing here, steam, you're going to go from steam at 115 degrees Celsius, it's going to lower down to 100 degrees Celsius where it's going to begin to change states, okay, from the steam to water. And of course, it will go from water down to 95 degrees Celsius. Okay, so we have a couple of different things going on here. First thing, we're going to have to get 115 degrees Celsius steam down to steam at 100 degrees Celsius. Okay, so it's important to note when you look at each of these little arrows, I've shown the formula that we're going to use. So in this case, we have mc delta T. M is your mass, C is your specific heat capacity, that's your constant, and of course delta T represents how much your temperature is going to change. Okay, I just got to fix my pencil here. There we go. Okay. Now, let's fill in our numbers from our problem, and we have the mass is going to be 100 grams all the way through. Okay, of course the substance may change states and be changing states here, but the fact remains you have 100 grams either of steam. 100 grams of anything is 100 grams. So you have 100 grams here of steam. This 2.0 joules over grams degrees Celsius, that is your specific heat capacity for steam. And of course, your change in temperature, you're going from 115 degrees Celsius down to 100 degrees Celsius, and that gives us 15 degrees Celsius. And this is an absolute value. Okay, we don't show this as a negative or a minus. It's going to be an absolute value. You're simply looking at how much does this thing change in temperature. Okay. Um, this too, let's just talk about this just for a quick second here. This too tells us, so in this case, you see this crazy um, this unit, joules over grams degrees Celsius. In this case, what this is saying is in order for this thing to drop, in order for steam to lower 1 degree Celsius, it's got to go all the way down to 100, but in order for it to lower 1 degree Celsius, 1 gram of it lower 1 degree Celsius, it's going to give up or lose 2 joules. So 2 joules of heat energy is required for 1 gram of steam to lower 1 degree Celsius. That's the way you would say it. Okay, and over here okay, so now we have steam. This has decreased its temperature down to 100 degrees Celsius. It hasn't changed states yet, so it's still 100 degrees Celsius. It's going to change states, and of course, that's going to cause our substance to go from steam, a gaseous substance, to liquid water. Um, Now look at this big number here, 2,260 joules over gram. Notice there's no degrees Celsius here because there is no temperature change. When something changes states, it'll change states. It'll remain at that temperature. The change of state will occur, and then it will either increase or decrease depending on which direction, what's happening with your substance. If heat is being added to it or if heat is being removed from the substance. In this case, it's being removed. It's being given off. So this number tells us, so that what this is saying is 2,260 joules of energy is required for 1 gram of steam to change to 1 gram of water. Okay, now we have 100 here, so we're going to plug in into our formula 100 grams times 2,260, and we'll get a number here in just 1 second. We'll plug these numbers in. And over here now, we have 100 degrees Celsius lowering to 95 degrees Celsius. Same situation here in terms of our substance. It's 100 grams. This number, 4.18, that's the specific heat capacity for water because this has successfully changed states. So what that tells us is 4.18 joules of heat energy is required for 1 gram of water to lower 1 degree Celsius. And of course, the change in temperature here is 5. Okay, and again, that's an absolute value. Okay, now let's look at the next page here. We'll plug in some of these values, see what we get. Okay, so quick jump around there. I know I've done the calculations ahead of time, so we can just look at them and talk about them. So when you take 100 and you multiply it by 2 and you multiply it by 15, you're going to get 3,000 joules. But we're going to cancel out grams, cancel there. Okay, they're going to cancel. And our degrees Celsius cancel. And we are left with a unit in joules, which is what we want because heat energy is measured in joules. Here we have 100, it's the easy one. 100 times 2,260 are grams cancel, and of course we're left again with joules. 226,000 joules of heat energy is required for steam at 100 to change to water at 100 if you have 100 grams of it. And lastly, we have 100 times 4.18 times 5, and again, the grams cancel there, okay, and our degrees Celsius cancel, and we end up with 2090. Now we're going to take each of these, because we're looking for how much heat energy is lost for this whole thing to take place, all the way from one end of this problem to the other, right? You've got three steps going on. There's one, there's two, and here is 3. So what we're going to do is we're going to take each little calculated section of this problem and we're going to add them together. So you would take your 3,000 joules and you would add um, 226,000 joules to it, and you would add 2,090 joules to that. This is our total when we add up the total amount of heat energy that's required. That's a big number. You can express this a couple of different ways. You have to go back and look at your initial problem. If you're answering using the proper number of significant digits, which I like to get my students to, then in this particular case, our answer should have 2 significant digits based on the data, based on our numbers. Okay, this has 2, this has 3, and this one has 4 significant digits or significant figures. So our answer should be expressed using 2 significant digits, and when you take 231,090 joules and express it using 2 significant digits, it would look like 230,000 joules. 1, 2, and then you're looking here. That's lower than 5, so we're going to simply round this to 0. Okay. If we were using scientific notation, then you would simply express it as 2.3 or 2.3 times 10 to the 5th joules of heat energy. So depending on how your teacher or your instructor wants your answer, he or she may want it expressed like that, or simply in scientific notation. And again, just a reminder, temperature, when we're doing these temperature changes here and here, they are expressed as an absolute value. Okay? And I hope that helps.